Alright, this is the midpoint video. Alright, the midpoint is a point on a line segment that divides it into two equal parts. Okay, the halfway point of a line segment. So when we mean two equal parts, okay, that means that both parts are going to be congruent. So if I take line segment AB and I put a midpoint in there, say it's C, then that means that both of these pieces are congruent. So that means that AC would be congruent to CB. There's also a formula, so if you're actually given the coordinates for these midpoints, or for these endpoints I mean, you're actually given the coordinates for A and B, then you can calculate what the midpoint is using this formula. Okay? You would have points x1, y1, and x2, y2, and then you would plug them in. You'd add the x's and divide by 2, that would give you your x coordinate of the midpoint. Add your y's, divide by 2, that would give you your y coordinate of the midpoint. Alright, so for example, if I'm given these two coordinates and I want to find the midpoint, I would start by labeling my coordinates x1, y1, x2, and y2. Okay, then I would go into my formula over here and plug in the points where they go. So for x1, I would take that out and plug in -4. So I'll have -4 plus x2. For x2, I would come over here. x2 I said was 5, and put that over 2. Then I would plug in for y1. y1 I labeled as 4 plus y2, which I labeled as -1 over 2 from the formula. Okay, and then just PEMDAS. Okay, so you'll PEMDAS the top. -4 plus 5 is +1 over 2, and 1 over 2 doesn't divide evenly, so we'll just leave that as a fraction, 1/2. Okay, then PEMDAS the top over here. 4 plus -1. 4 plus -1 is really 4 minus 1, which is 3 over 2, and 3 over 2 also does not divide evenly, so we would leave that. Okay, so we'd have 1/2 and 3 over 2. You could, if you were told it was okay, change that to a mixed number, which would be easier to graph, so that would be 1/2 and 1 1/2. Also, if you were told it was okay to leave it as a decimal, you could have 0.5 and 1.5. Okay, so just go with whatever the directions are that day. Alright, so again, I would start by labeling my points x1, y1, and x2, y2. Okay, then I would go over here and just start plugging in. So x1 is -1 plus x2, I labeled as 5, divide by 2. y1 I labeled as 1 plus y2, which I labeled as -5, divide by 2. Okay, and then you would PEMDAS the top. -1 plus 5 would be 4, divide by 2, and then 4 divided by 2 actually divides evenly to give you a 2. And then over here you'd PEMDAS the top. 1 plus -5 plus negative is really just subtracting. Okay, so 1 minus 5 would be -4 divided by 2, and -4 divided by 2 also divides evenly to give you a -2. Alright, in this particular example they didn't give you the points, like just straight gave you the numbers, they gave you a picture. So from the picture you can count your coordinates. So for this coordinate right here in blue that I highlighted, you can figure out what that coordinate is by counting from the origin. That'd be left 1 and down 1. So that coordinate, that blue coordinate, would be -1, -1, left 1, down 1. Okay, this one down here in the corner that I'm highlighting in red, again, you'd start at the origin and count left 1, 2, 3, 4, 5. Left is negative, so that would be down at our left -5, and then down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. Okay, so those would be your 2 points, your 2 coordinates. Okay, you had to count them off the graph first, and then you go over here and plug in just like you did before. x1 would be -5 plus x2 would be -1 over 2. y1 would be -5 plus y2 would be -1. And then PEMDAS. Okay, PEMDAS the top, -5 plus -1 is really just -5 minus 1, which would be -6 divided by 2. -6 divided by 2 is -3. Okay, and then PEMDAS over here on the top, -5 plus -1. A plus negative is really just a minus. -5 minus 1 is -6 as well. -6 divided by 2 is -3. So your coordinate here is -3, -3. Okay, and that would be right here. Left 3, down 3. That would be the midpoint. Alright, this one's pretty different. It says find the other endpoint of the line segment with the given endpoint and midpoint. So they're not giving you both endpoints and you're just plugging it straight in to find the midpoint. They're giving you the answer, they're giving you the midpoint and one of the endpoints. Okay, so using that same formula, okay, if you labeled this as your x1, y1, and this is actually your answer, okay, in your formula, we'd still have x1 plus x2 over 2, and we'd have y1 plus y2 over 2, but we're not given x1, x2. We're not given those 2 points. We're actually given the answer. For the answers here, this would be the answer for x, and this would be the answer for y. So if you plug in and solve, okay, if I plug in -1 for my x, plus the x that I'm missing, equals -9. Okay, same thing for y. If I plug in the y that I have, which is 9, plus the y that I don't have is y, equals -10, then I can solve these and I'll find the other endpoint. So you're working backwards. Okay, in order to get rid of a denominator, you multiply by 2. So you'll have -1 plus x equals -18, and then add 1. Okay, so x would be -17. Okay, over here you would times by 2 and get 9 plus y equals -20, and then subtract 9. So y would be -29. Okay, so your answer, your endpoint, we already had the midpoint, but the endpoint would be -17, -29. Okay, and this one, these are a little bit harder because you're plugging in and working backwards. Alright, and then just a couple of definitions. A segment bisector. It says a line or a line, ray, or segment which cuts another line segment into two equal parts. So if I have a line segment AB, I can make, there can be a segment bisector that could have been a ray, and that would have just cut the two segments in half. It could have been a line that cut them in half. It could also have been a segment that cut it in half. Okay, so if the whole thing, if AB was 50, from A to B, if that whole thing was 50 and we had a segment bisector, that would cut it into two equal pieces. We'd have 25 and 25. Segment bisector just means it cuts the segment in half, it bisects it. Same thing, a perpendicular bisector is still a bisector. So the perpendicular bisector is a line that divides a line segment into two equal parts, which is what we just talked about, but it also makes a right angle with the line segment. That's why it's called a perpendicular bisector. Each point on the perpendicular bisector is the same distance from the endpoints to the original line segment, which we won't be using now. We might use that later with triangles. So AB, if we have a perpendicular bisector, it can be a line, a segment, or a ray again, but it would make a perfect right angle. It would still cut AB into two equal pieces, but it would be a ray that's at a right angle, or a line, or it could just be a segment, but it would be at a right angle, okay? But it just cuts it in half.